A researcher takes sample temperatures in Fahrenheit of 17 days from New Orleans, Group 1, and 17 days from Salt Lake City, Group 2. Test the claim that the mean temperature in New Orleans is different than the mean temperature in Salt Lake City. Use a significance level of alpha equals 0.05. Assume the populations are approximately normally distributed with unequal variances. You obtain the following two samples of data. Round answers to 4 decimal places. Okay, so we certainly have a lot of information to parse through, and it probably makes sense to just take a moment to make sure we fully understand the problem before we start jumping into how to solve this. First thing, when you work with any hypothesis test, make sure you know what the claim about the populations is. I tend to highlight that statement in the problem. Sometimes it's at the beginning, sometimes it's toward the end, but let's read through and find out. So we have sample temperatures in 2 different cities, and the second sentence here, test the claim that the mean temperature in New Orleans is different than the mean temperature in Salt Lake City. So that means my claim here, and we were told to use New Orleans for Group 1, so the mean temperature in New Orleans, which is Group 1, is different. So different means not equal to. Could be greater than, or could be less than. Either way, it's different, so it's not equal. The mean temperature in Salt Lake City, which was Group 2. The sample data, I'll go ahead and highlight. So we have sample temperatures of 17 days from New Orleans and 17 days from Salt Lake City. Okay, and the individual data values here are listed for us, so we actually have the sample data itself rather than the statistics. So that's make sure we take care of that as we go through the problem. Use a level of significance of 0.05. Okay, and then assume the populations are approximately normally distributed with unequal variances. That information is important. We'll use it as we get to the part where we're doing calculations. For now, what we have are 2 different populations that we are comparing the mean of. So that helps us understand what function we're going to be using ultimately to find our statistics. But we can take our claim at this point and create a hypothesis from it. And the claim has no statement of equality, so that means it will be placed in the alternative hypothesis. If it had a statement of equality, we would put that in the null. I'll go ahead and mark that was my claim and put the complement to that in the null hypothesis. Okay, based on the hypotheses, find the following: a test statistic and a p-value. Now I have sets of data here to work with, and those sets of data are each have 17 data items, I was told, but what I really need is the mean and standard deviation of that set of data. Now there is one way of achieving that. You can put the data into lists, and I've already done that for simplicity, but you'll need to pause the video and do that. You could then calculate the mean and standard deviation of those lists, plug that information into the program that we ultimately use to get the test statistic and p-value. But what is nice is that the calculator, when you use 2SAMP z-test or 2SAMP t-test, you have the ability to work from lists of data or from the statistics of that data. So we'll switch over and we'll use the data mode. But before we get there, let's make sure we understand why we're using 2SAMP t-test as opposed to 2SAMP z-test. 2SAMP z-test is based off of the normal distribution, and to use it you must know the values of the population standard deviations. And the values of the population standard deviations are not provided here, so we're using the t-distribution. Okay, so the input, you can either make it come from statistics, where you would enter the mean and such, or it can come from sets of data, where you just reference where that data is. So the data for group 1, we put in L1. The data for group 2, I placed into L2, so that's fine. I have no frequency data, so you're going to want to just set that to 1, and that just tells the calculator that all of your data items appear with a single time in your data set. And that's the same for both sets of data. Now we need the type of test that we'd be using. And we look to the alternative hypothesis. Since there's a not equals, that tells me I have a two-tailed test. And essentially in the calculator you just need to match that you have a not equal symbol, so that's checked and good. Now we come down to this option that says pooled. And what happens here with the pooled idea is if you have population variances or population standard deviations that are roughly equal to one another, then you'd want to pool your variances. But most of the time, problems in an elementary stats class are such that the populations have unequal variances. And that's even why that's specified here. So we say that pooled is set to no. Just leave that checked the way it is at this point, and hit calculate. And the first item that shows up is t. That's our test statistic, so 3.3608. And I'm just taking that to 4 decimals because that's what was specified. Just follow the rounding rules given to you. P is 0.0028. Okay. And now we need to take that p-value, compare it to our level of significance. So the p-value is 0.28%. The level of significance was 0.05, which is 5%. So the p-value here is much less than the level of significance. And the rule is, if p is low, the null must go. So since that's the case, we reject the null hypothesis. So the correct summary would be, at a 5% level of significance, and this isn't always requested, but I think it's always a good idea to present in your final answer, because really a different value of alpha can provide different results. So at the 5% level of significance, there is enough evidence, and we say is because when you reject the null hypothesis, you pick the stronger of the two results. So is, if you had failed to reject the null hypothesis, you pick the weaker of the two results, which is the words is not. So is enough evidence to blank the claim, and the claim is falling under the alternative hypothesis. And when the claim is in the alternative hypothesis, we are trying to support it. And if the claim was in the null hypothesis, we would be trying to reject it. Now, if you want to understand the logic behind that, instead of just memorizing rules, which is fine, this is how that works. So we rejected the null hypothesis. So we effectively said that the null hypothesis was a false statement. And because the null and the alternative are complements to each other, that sort of implies then that the alternative would be true. And if the alternative is true, then we are essentially saying the claim is true because the claim was the alternative. So we need to choose the language that says that the alternative is true, or that the claim is true. So there is enough evidence to support the claim that the mean temperature in New Orleans is different than the mean temperature in Salt Lake City.